Okay, last example. And so this one we're going to look at the equation of a direct variation. So Brian owns a repair garage. He has 4 cars scheduled for service today. He charges $72 an hour for labor, and he estimates how long each job will take. 1.3 hours, 2 hours, 1.8 hours, and 2.5 hours. So write an equation to model the solution. So if I were to try to figure out, let's just look at 1.3 hours. So I would say, if I wanted to know how much that would cost, I would do the amount per hour, $72 per hour, times 1.3 hours. And I would get, I don't know why I need too many signs there, $93.60. Okay, so what I did there is I multiplied the amount per hour, which doesn't change, by the number of hours. So if I want to know how much he's going to charge, I might say C for the cost or the charge equals $72, which is the amount per hour, times the number of hours. And I'll put T for time. You could put H for hours. It really doesn't matter. So use the equation to figure out the labor costs for all 4 jobs and then the total labor per day. So we already did 1.3 hours, right? We said 72 times 1.3, but we can do it again. So 72, 1.3. So the cost for the 1.3 hour job is $93.60. So then the 2 hour job, so we would say the cost is 72 times 2, which would be $144. For the 1.8 hour job, so we would say the cost is 72 times 1.8, which would be $129.60. And then the 2.5 hour job, 72 times 2.5, so the cost would be $180. So the total amount earned, all we need to do is add those up. We'd add them all up and we would say the total amount would be $547.20. So we'd add up the 4 charges. So predict what the graph might look like. So I know that 0 hours of labor would cost, sorry, I don't know why I need a number sign on hours. 0 hours of labor would cost $0, right? So this would be a initial value or a y-intercept of 0, right? My rate of change would be $72 per hour, because for every hour I work, my cost is increasing $72. So this would make this a multiple, right? So y is always 72 times x. So whatever x is times 72, we get y. So that means that this graph would be a direct variation. Variation, which means it starts at 0, 0, is linear, and has a slope of 72. So that's what the graph would look like. How does the graph relate to the equation? Well, it's what the equation would be is the y value equals the slope times the x value. And we write that as, usually we use the letter m for slope, so y equals mx. And we had our y value is the cost, our slope is 72, and our x value is the time. Okay? And that's how we make an equation from a direct variation.